Welcome to this course on C programming with puzzles from in 28 minutes. Let's start with a question. How do you want to learn to drive? Do you want to sit at home, read about it, and watch somebody drive? Will it really work? I'm sure it wouldn't. Programming is very similar. We have created this course with a lot of hands-on examples, and what's more, we use more than 100 puzzles to illustrate advanced concepts. In this video, we would look at functions with a lot of examples and puzzles.
Now let's switch to functions. We discussed a little bit of functions earlier, but let's get a deeper understanding of functions now. What you're seeing on the screen is a simple program. Int main, it's printing welcome to in 28 minutes thrice. When I run the program, this is the output I get. Welcome to in 28 minutes. It's printing on the same line. I don't like this. /n for the third time runs. Okay, this is good. Now I missed .com. Let's add .com everywhere. Okay, yeah, please do save. Okay, that works. That's cool. But what you would have seen is I have to make 3 changes for any change that I would want to do, even though I'm doing the same thing 3 times. And this is where the functions come into picture. I kind of can create a function which can do this, and then I can call the same function thrice. Then I would not need to modify the same thing again and again. And that's what we would be doing now. So the way you can create a function is something of this kind. First thing is return type of the function. Return type of the function, name of the function. So name of the function, first is return type, name of the function, open bracket, close bracket. Actually, there are something called arguments we will talk about later. There are no arguments in our first example, so I'll remove that. Then the next thing which would come in is the open brace to indicate start of the method and close brace to indicate the end of the particular method. And in between is what is called body of the method. The body of the main method contains 3 statements: printf, printf, printf. Whenever we create a function, we would need to have the body also in there. So let's create a small function. So I'll say return type, I don't want to return anything, void. So void means I don't want to return anything. Name of the function is welcome. So I want to call this function as welcome. Open parenthesis, close parenthesis, open brace, close brace, and between that I want to print welcome to in 28 minutes. So that's it. That's a new function. It's as simple as this. Now here I don't want to use this particular thing. So now I don't need to do all this stuff. So whenever I want to do this, I can say welcome, and that's it. The function is called. This is called invocation of a function. So whatever we are doing is here is calling a function or invocation of a function. Whatever we are doing in here is we are defining a function. So we are giving a definition for this particular function, and whatever we are doing in here is calling or invoking a function. The first line of the function is also called the signature or the declaration. So declaration or signature. The first line is called declaration, and the complete this thing is called the definition of the method. So let's make it very simple. This is declaration. Whatever is highlighted is the definition of this particular method, and whatever we are doing is called invocation. One more time, this is the declaration. Declaration is what is the return type, what is the name of the function, what are the arguments. That is declaration. Definition is declaration and also the body of the method. So definition of a method contains the body of the method as well. The invocation is where the method is called. So now I'll call welcome, welcome again, and now I'll run this program, and you would see, there you go. You see, welcome to in28minutes.com is printed thrice. If I want to change something, I don't like a capital I. I really like the small I thing in here. I make one change, and you would see the change reflected everywhere else. That's the beauty of using functions. The reason why we prefer using a lot of functions in programming is because With functions, they avoid duplication of the same logic. Earlier, I had this present 3 times in my code. Now it's present only once in my code. Thereby, I prevented the duplication, and also it improves the maintainability. So whenever I want to change something, I don't want to call welcome to in 28 minutes, or I want to change this from hi from in28minutes.com. All that I do is change one place, and wherever it's called, the change from that particular function is reflected in all those places. That's the beauty of. Until now, we looked at loops. We understood how to use a for loop, while loop, do while loop to print the content of an array. Now, we will focus a little bit more on functions. We will specifically focus on passing parameters to a function. I mean, what are arguments of a function and how do we pass values to them? That is the focus for this section. Now, we have a small program to print the scores. Let's say there was another scores array in here. Let's say the first array contains scores of team 1. Let's say these are scores for team 1 and these are scores for team 2. And let's say yeah, obviously the scores would be different. Let's just make them different. Probably one of them is the same. So these are the scores that the team 1 scored. These are the scores team 2 scored. Now I want to print those values. The problem is, if I want to print the values, the logic, I have to repeat it again. So I have to, let's for now assume that both the arrays have the same length. So team 2. So I have to copy the code over, and now I would be able to print the scores of both the teams. But this logic of looping over the array and trying to print the scores is repeated, and that's what we try and avoid when we use functions. So let's keep it simple for now. Let's not worry about the complexities of having the second team. Let's start with creating a function. So what I'll do for a start is just create one small function. As we looked at earlier, the way we create a function is we start with return type. So return type, I don't want to return anything. I want to print the content of this course. So it's void. Void means a function does not return anything back. And next goes the name of the function. The name of the function I want to do, I mean, what do I want to do in the function? I want to print the content of the array. So I'll say print array. I mean, I could make it more descriptive, saying print array to console or something of that kind, but yeah, let's keep it simple for now. And now I want to do all this stuff in the print array function. Okay, there are a few things that we'll discuss. For now, let's just do this. So I moved all the logic which was there in main to the print array function. It's good practice to have return 0 everywhere. If you saw a few of the example programs earlier not having return 0, always return something back to the to wherever your program is run from. 0 in case of success, and probably you can define other values as well. But that's okay. That's got nothing to do with the specific discussion that we are having right now. Print array. So now I moved the logic to print array. In main, I'm just doing a return 0. Will print array be executed? Will it get executed? Think again. As we discussed over last few videos, only main function is executed and whatever is called from the main function. So if I don't call the print array from the main function, nope, it will never be run. So now I'll do a print array. So that's good. So now I can do a right click, run as local C++ application. Okay, there you go. Print array is done and I see the content of the array in there. That's a good start. However, if I want to print the content scores for team 2, I have to again duplicate the logic. So it didn't really solve my problem, but at least now I've moved some of the code to a function. So what I want to be able to do for now is I would want to be able to pass this score length from main. So instead of
being here, instead of score length being here, I would want to be able to pass the score length to main. So instead of, so I would want to be able to say print array and pass this course length in here. So this is called passing arguments. We saw how we pass arguments to printf earlier. So similar to that, I want to do print array course length. So how big is this course array? I want to control from main for a start. So I'm giving course length, and what should I do to make it have something in here? That's where the magic of arguments come into picture. So what is the type of course length? It's int. So I can say int course length in here. What happens in that situation is whatever course length I'm passing from main is passed as an argument. So this is called an argument. Here it's called a parameter. Here it's an argument. Return type, name, arguments. When we call the function, we pass the parameters. So we pass the parameters and get it in argument. But actually, all this nomenclature you don't really need to care about. So whether it's called parameter arguments, doesn't really make sense. But what you need to understand is the fact that whatever course length is here, it gets passed to this function, and you can almost use it like a local variable in here. That's the most important part. And now this 4, if I change to 5 and run it, this is just to show that this is being controlled from here. So you would see that it prints the 5th value as some garbage value, whatever was in the next memory location. 0 comes here, but it doesn't necessarily have to be 0. It could have been anything else. So if I put 15 in here, you'd see that there would be a list of 15 values printed in here. So you can see the values at the end are not really controlled by us at all. So the good thing now is we have passed the length of the array as an argument from here. To really make use of this function, I would want to also pass the actual content of the array using an argument as well. So I would want to move this out as well to main. So I'll do that here. I'll put the original length back, which is 4. So now we have 4 elements in the array. Length is 4. That's perfect. But yeah, score stream here, score stream 1 is not really defined. So what I'll do is I will need to pass the score stream 1 to the print array. But does print array, did we declare a second argument? Not yet. So let's go ahead and do that. What is the type of score stream? It's an integer array. The way we can define it is something of this kind. So int and scores. This says scores is an array. Scores is an integer array, and I want to pass scores integer array to this particular function print array, and that's how we do it. Now let's use the scores instead of the scores team. I called it scores instead of scores team 1 because really here it doesn't have to be the scores of team 1. We could eventually use this function to print the content, print the scores for team 2 as well. So in general, any scores can be printed, so I just changed it to int scores. My IDE complains about the brackets being in the wrong position. I'm putting them after the name of the variable. So we called it scores, and I put the brackets at the end of. Let's go ahead and run this program. Right click, run as local C++ application as usual, and there you go. There you see some output, 10, 101, 25 and 47 being printed. That's basically the content we had in the main. So the great thing about this particular program, now I can use the same program to print another array as well. The same function. So I want to print the marks of team 2. So let's say 101 and 100, 5 and 7. This is the opposition team. I don't want them to make a lot of runs. 101. Too much. Okay, let's use this. So now the great thing is I can actually use the print array function to print the scores of team 2 as well. So now let's go ahead and run this. Run as local application. There you go. It's printing the values of both the things, like 10, 101, 25, 47 and 10, 100, 5, 7. I could have made it very easy by actually making a printf. I'll just print a slash n at the end of the print array, so that after every team it would print. There you go. So it prints a new line, and you see that we are able to print now the arrays by just calling it in this way. So as you can see here, it's very easy now, and that's the reason why it is recommended to use functions to do a lot of things. So if you see something that you keep doing repeatedly, then try and create a function for it. Try and think what would be the right parameters for it, and try and make it a function. Now let's look at little bit at making our print array function a little more better. One thing I don't like the fact is that I have the length first and the scores next. So I'll change that out. Int scores. Actually, it could print the name of the variable. I don't like it to be scores length. I'll just make it simpler. So I'll call it length. And now I can change. I can pass this, make the change same change, reverse the order of parameters, because I have to first pass in the array and then the length of the array. So also the other thing is, now this print array function not only on scores, you can pass any array to it and print the content of it. So I'll not call it scores, I'll call it ARR, or you can even call it array, and there you go. Nothing changes in the output. So now I can print any array, not just the scores, but any array I can print by using this particular function. And that's the beauty of writing functions, really good functions, because now this is reusable. I can use it in any situation where I want to print the content of an array to the console.
Now let's get down to one of the favorite programs of interviewers. This is a swap function which I have written. So in swap, I'm passing an integer, a couple of integers actually, a and b, and I'm trying to swap them. If you are interested in why we need a temporary variable, here I'm creating a temporary variable int c is equal to a, so that you'd be able to swap it. So if the logic which we wrote is something like a is equal to b, b is equal to a. Take some time and see if that would swap the numbers. It would not swap the numbers, because when b value is stored into a, the value in a is lost. So if a had a value of 3, let's say, and b had a value of 5, and after I do a is equal to b, both a and b have the value of 5, and the value 3, which was the value of a before the assignment, is lost. So what it does effectively is, the value of a would have the new value, that's the value of b, so that would be 5. So 5 would be stored into b, and this is not really an effective operation. So this will not really work. So this is some logic which works for a swap. C is equal to a is equal to b, and b is equal to c. So you are taking the value of a and putting it in the temporary value variable c. So it's a temp variable c. Sometimes we write the program as this as well, so that it's much more clearer. So in temp is equal to a, so I'm storing a into a temporary variable and then overriding the value in a with the value in b, and then I would copy the value of temp into b. So now the values a and b are swapped, but would the swapped values reflect in main? That's the main thing that we want to find out in this particular puzzle. So I has a value 5, j has a value 7, and I would want to swap the values I and j. So what would be the output of this particular program? You can pause the video now and try and guess the output. The answer to that question is the values will not be swapped. Let's try and run this program. You'd see that both the times the values of I are 5 and I and j are 5 and 7. They are not really swapped. Why are the values not really swapped? It's very important to understand what happens in the background in here. So let's bring up my favorite spreadsheet where I kind of track the values in memory. So we have values I and j. Let them be stored at certain memory locations somewhere in memory. They have a value 5 and 7. I'm assuming the size of a memory location here is 2 bytes and the size of int is 2 bytes. It might be little different on based on the compiler and the operating system where you are working on, but let's just assume that. Let's see what would happen. So at this point, the value of I is 5 and j is 7. So I is 5, j is 7. And we are calling the swap function with passing the values of I and j. So on line 11, we would call the function swap. So what would happen is main would be pushed onto the values in main would be pushed onto a stack, and now we would be in a function called swap, and the value of I would be copied into A, and the value of j would be copied into B. So there would be two new variables created. So A and B would be two new variables somewhere in the memory. They can be, let's just assume, a couple of memory locations. So they would be copied in some place else in memory. So the value of I is copied into A, the value of j is copied into B. In C, everything is called by value. I mean, we will discuss that a little later as well when we talk about pointers in detail. But in C, everything is passed by value. So the value I is copied into 5 and the value of j is copied into B. So now, things which you are swapping in here, in temp is equal to A is equal to B, B is equal to temp, would be the values of A and B. So what would happen is by the end of the entire operation, the value of A becomes 7 and the value of B becomes 5. So when the program completes executed, the swap completes execution, these two things will be pulled out of memory. So this will be completely taken out of memory, and there would not be A and B in memory at all. And the program comes back to I and j, which are in main. And the values of I and j we did not touch at all. We will not be able to change them at all in this particular way. And that's how any function call works. If we really want to swap the values of A and B, we need to use pointers, and we will look at that a little later when we discuss about pointers. Now let's look at this program. In this program, in the function, instead of passing a normal int variable, I'm passing in a array. So I'm passing in an array. So I'm creating an array called marks and passing add 1 to the marks. So there's one favorite student of mine who's only getting 34 marks, and I want him to pass. So I want to give him 35. So I want to add 1 to his marks alone. So I want to do this. The thing which I want to check now is whether the change I have done in the function gets reflected in the main function. That's exactly what I want to check. So now try and guess what would be the output of this program. Pause the video and come back. Welcome back. Let's run this program and see what the output is. So the output is mark 0 is 34. As expected, here the value is 34. Here the value is incremented to 35. So earlier when we did this on an integer, so if this was an integer, so int a plus plus, and let's say marks is equal to 34, and I'm printing the value of marks. So I quickly change the program around to see if when marks is an integer, you'd see that actually it's not marks of 0. Please bear with me. It's marks 34 and 34. So the value of I, when you are passing an integer, does not change. But when I make it an array and pass the array, you'd see that the values change. So the marks of 0 is incremented and becomes 35. What's the reason? Let's try and understand that. Earlier we saw marks. So what was the value of marks? 34. So if we don't use an array, the way this program would work would be something of this kind. So the marks in main would be a value 34. When I call the function add1, and add1 is accepting an integer a. So what happens is this integer a is created, value of marks is copied into this a. So 34 is copied into a, 34, and I'm doing a plus plus, so 34 becomes 35, when the program returns back, marks would still have 34, and this value of A would be removed from memory. What would happen in the case of an arrays? In the case of an arrays, the way it works is a little different. When I create an array of the kind that we are seeing on this program right now, so marks is an array with 3 values. So when I create an array, there are actually few things which I create. First thing, which is the value of the name of the array. So the name of the array here is marks. So there will be a variable with name of the array created, pointing to where this particular array is stored in memory. So let's say this array is stored in memory at 6006. So that's where this marks array is stored in memory. So the way it would be is this marks variable would have the address of the first location of the array, 6006. So 6006 is where this array would be stored. So 6006 would have 34, 45, and 67. So consecutive locations, this is how the array is stored in memory. Actually, this would be 6010 and so on. So these 3 are the values which are present. Now let's see what happens when the add one function is called with the max array. So what would first happen is the entire array doesn't get copied. So when an array is passed, the only thing which is passed in is the address of the first location of the array. So what gets passed in is actually like, let's say it's stored somewhere at 7010. So let's say the variable A array is stored at location 7110. What gets copied is the value 6006. So the value 6006 gets copied. That's where the array is stored in memory. So what gets copied, so what gets passed here is not the entire values in the array, but only the location of the first element of the array. That's 6006. So that's what gets copied over. So A gets the value of that. So what would happen when I do A of 0 plus plus? What it does is it really goes to the first element of the array that's pointed by here, 6006, that's pointing here. So it goes here and it increments this value 35 and comes back. Once it comes back, this value is removed from memory. So this value is removed from memory. A is no longer in memory, but marks is still in memory. So marks, it's pointing to 6006 and 6006 has a value 35. So the incremented value is present and that's why the incremented value is printed. So this is how the whole thing works. The most important thing to realize in here is that since not the actual array, the entire array is not copied. The only thing which is copied is the location of the array. So when you make any modifications to an array in a function, you are actually modifying the original array itself. So you're actually modifying the original array and the values are reflected back inside the main function as well. So now that's a very important thing to understand. When you pass an array, the values which you make, changes which you make in the array are reflected back in the main function. But if you pass a primitive variable, then they wouldn't be, because a copy of the primitive variable will be passed. But when you pass an array, the address of the first location is passed, and when you change the values inside the array, then those values are reflected back to the calling function. So those are a few important things, important puzzles, if you want to look at it that way. Now let's look at a few more things about functions. As we all know, there are simple concepts called arguments, parameters, return values related to any function. This is related to any programming in general. The way you can look at it is, let's take the example which is on the screen right now. So I am calling a function called double the value. I'm passing a 4. It's returning value into 2. That's basically what it does, is it takes the value which is passed in, multiplies by 2 and returns it back. Actually, you don't really need a function to do it, but this is a very simple example I've considered to explain the different parts of a function. So the 4 here is called an argument. It's received into a value here. The value is called a parameter, and the value into 2, which is returned back, is called a return value. Now in this particular example, let's look at all the possible variations. What happens if a parameter is not declared, or if an argument is not passed, or a written value is included? What would happen in those scenarios? Let's look at that right now. Let's just say there's an argument, right? I'm passing an argument 4. So if I run this program, you know what the output will be. 4 is passed, 4 into 2 is 8. So now what I'll do is I'll remove this 4. So now I'm removing the value, the argument which is being passed to it, and let's see if this program compiles. What do you think? It gives an error because the value is expecting too many parameters and you are not passing any. So that's an error. What would happen if I pass too many arguments? So it's expecting only 1, but I'm passing 2. Again, it's giving me an error. Too many arguments to a function call. Now, let's take another example. Let's remove the value 3 and let's run this. This goes ahead as so. If you see the different things that we have tried with arguments, too few arguments, too many arguments, and all that kind of stuff, you can see that the behavior is inconsistent. So, and that's exactly the summary is. So, when you pass too many parameters or too few parameters, the C language doesn't define a particular way the compiler should handle it. So the C language specifications do not say anything about them at all. C language specifications assume that you are passing the same number of parameters that you have defined, or the same number of arguments that are defined for that particular function. So if you pass a few less values, few more values, then it might result in a compilation error, or it might result in a garbage value. So that aside, let's move on to the next thing about the return values. The thing is, this function is saying I'm going to return a long. Let's make it int to make it easy. What would happen if I don't really do anything with the value which was returned? So W value, I'm ignoring the return value. So it will not give you an error. It prints some garbage value because I is not really initialized. But the thing is, it's not giving you a compilation error. So it's not an error to ignore the value which is returned from a function. So that's okay, but it's not really good programming practice. But it's not a compilation error. And let's say this function says I'm going to return an int, but let's say it forgets about returning an int. And let's say this statement is removed. So it doesn't really return anything. So does that give a compilation error? No, it doesn't return a compilation error. The value which is being printed here is 0, but actually that could have been anything. It's basically some garbage value which will be returned back, and yeah, that's what would be printed in here. So it's not really an error to ignore a return value. Neither is it an error to not return a value. We are talking about C language here. In other languages, the functionality might be a little different. But in C, you can ignore return values without a problem, and you can ignore actually returning a value from the function as well. So that's not really a problem at all. The other thing is whatever type conversion that needs to happen. So if the return type is int and I'm storing it into a long, that's okay. And even the reverse is okay, but there would be truncations and all that kind of stuff which would be happening. So if the return type is compatible with whatever is being passed, then it's okay. But if, let's say, this is returning a void. So let's say this function is returning a void and I'm trying to take the value and putting it to an integer. That's not allowed. So if you see this would give a compilation error because void is saying I'm not returning anything and I'm trying to take it into an integer, and that's not allowed. However, if this was returning a long, let's say, it was saying I'm going to define a long. I'm going to return a long, let's say, that's what it says. That's okay. Because the typecast would happen long to char, and even if it says it's char is smaller than int, but even then the truncation would happen. Whatever truncation that needs to be happening will happen. But if it says it's incompatible, I mean, if it returns an incompatible value, then it would throw an error. Let's say it was saying something like, I'm going to return a void, or if I'm in these kind of scenarios where the return type is incompatible to the value where it's being assigned to, then it would result in a comparison. If there is a conversion possible, C would do that for you. The last thing we'll look at now is what would happen if a structure is passed to a function. Previously, we looked at passing a primitive variable. We looked at passing an array. When we did for a primitive variable, whatever change which we did in the function was not reflected back, because a primitive variable, the value was passed and the change was not reflected. For an array, the address value of the first location of the array was passed. So the value of the first location of the array was passed, and when we change something, actually the array was being modified. So the changes in an array reflected. So in an array, the changes were reflected. However, when we passed a primitive variable, the changes were not reflected. Now let's pass a structure. So I've defined a small structure, struct point int x int y. So this structure is nothing but it consists of two things, x and y. You can think of a structure as combining related values. So a point in geometry has two coordinates, right? X and y coordinate, x coordinate, y coordinate. So I'm putting both of them together and I'm calling it point. So this struct point, now on, it acts like a variable type. So you can define variables of that particular type. If you want to learn more about functions, further down the line, we'll talk a little bit more about functions in a future video. For now, let's just assume that a structure is being passed. So a structure instance is being created in here. Point 1 is equal to, I'm assigning x a value 1, y a value 2. I'm putting a point 1 and I'm printing the values here. Next, I'm calling a change value point 1. So this function is incrementing the x and the y, and I'm printing the values after that as well. So now, what would be the output of this particular program? Think about it and come back. Let's run the program. So you can see that the values are not changed. X remains 1, y remains 2, x1, y2. So let's see what happens in the background. So what we did is we created in main, we had a point 1. This point 1, we assigned a value, x value of 1 and y value of 2. So this is how the point 1 is stored in memory. So that's how it. Now what we did is we passed this argument to the change value function. So in the change value function, we created a variable called, we created a parameter called point. The way it happens in C is when I pass a structure to a function, then the values are copied. So what happens is these values 1 and 2 are copied to another copy. A copy of the structure is made. So x and y are there. So this point structure is created. An instance of this structure is created with x and y values, and the values are 1 and 2 respectively. So now in the function point.x++, so what it does is it gets incremented to 2, point.y++, this gets incremented to 3, and once the function returns back, these two things go out of memory. So the point variable goes out of memory once the function change value completes execution. So the original values in the structure point 1 will remain unchanged. So that's why it's printing x1 and y2. Let's just say we print the values in this particular function. So let's say I printed the values point.x and point.y in the function. So I'll just call it change value, and I'll print the values inside the function change value. You'd see that here the values are modified. So the values are changed inside the function. So in the function itself, the values are incremented. X is incremented, y is incremented, but it's a different copy. So this point is a new copy of this point 1. So whatever changes done here are not reflected back to the main function. So the way you need to understand is when a structure is passed to a function, the original instance is not passed. What is passed is a new copy of that structure. And whatever modifications you are making are made to the new copy and not to the original structure itself. So the values are not reflected back to the calling function. In the function which is called, the values reflect. So in change value, you can see the modified values. But once you go back to main, you are actually pointing to the original structure and the values will not be reflected back in that particular function. So I hope this discussion is clear about the arguments, parameters, return values, and we looked at how we would pass a structure, and we looked at how the values which are changed in a function directly done to a structure are not reflected back to the calling function.
If you are preparing for C interview, we have a complete C interview guide available. And if you are preparing for a C aptitude test, then we have C puzzles for interview as well. You can find the links to this in the description of this video. If you loved this video, then we are sure you'd love our other courses as well. We have more than 10 GitHub repositories with examples on C, Spring, Java, basic web application, Maven, Mockito. Whenever you are in need for examples, you can look these up. We have a number of courses created on ChalkStreet as well. You can search for in 28 minutes in chalkstreet.com, and there you go. Right now we have 3 different courses in here. I'm sure there will be a lot more courses and we have a lot of courses on C, Java, Spring, and a lot of Java related frameworks and web applications on Udemy as well. You might like some of the most watched videos on our YouTube channel. We have courses on design patterns, web applications, Maven, Spring, Eclipse, and web applications as well. Good luck with your learning. All the best for you. Until next time, bye-bye.